Okay, welcome back, boys and girls, to part B of this lesson. So before we, excuse me, before we go on with the solve and share, I do want to briefly review some things that we went over last lesson to help us moving forward with our solve and share that we'll discuss in a second. So as a review, last week we talked about different types of polygons. So what is a polygon? A polygon has and you see how color coded for you, has very specific attributes or characteristics. Polygons have very specific attributes or characteristics. And so there are 4 different attributes or characteristics of each and every polygon. It is a closed figure, right? As you see, these 4 quick examples are polygons because they are all closed figures. There's no open spaces or there's no gaps there for you to see in these objects. Every side is straight. And for the most part, I try to do a quick figure. And just for argument's sake, we will say that these figures are they are straight lines there. 3, it has corners wherever 2 sides meet. And of course, again, we're looking at the corners where 2 sides meet. This is a review here from last week. Where those red dots are, those are what once again, we're talking about the corners wherever 2 sides meet. And then finally, the corners that we're talking about, yeah, that's right. The corners are from our vocabulary on last week. Those corners, each corner is called a vertex. So that was a quick review for polygons last week. And then we want to review to move forward with our lesson for today. So you can always pause this, boys and girls, once again, to go back and review. So we're going to move forward. So also, in our lesson on last week, we talked about 3 different angles. Right? And we always started with our benchmark angle. And you remember this from the lessons. I hope you all still remember the integrated PE lesson when you did your angles dance. And a lot of you all did comment on that, how you all enjoyed that. And so that's, I'm pretty happy and excited that you all did enjoy that. Because of course, there's always different ways that we learn in math and dance, rapping, and music are some of the ways that we try to get our math lesson across. So thank you. Just a few shout-outs. Thank you, Jacob. You said it. Thank you, Makai. Thank you, Sincere. Thank you, Sincere's mama. You know, thank you, because she said it stayed in her head, the dance. So that's what it's all about, okay? So thank you for those messages. Keep messaging me about the lessons, how you enjoyed them or the lack thereof, okay? So we have our benchmark angle here, our right angle, And of course now for review, we would know now if it has this symbol, then we automatically know that that is a right angle, and where two lines meet, of course, we said that that's the vertex. Okay? Now, so when we did our lesson with right angles, we also said, it's also worth noting, because this will help you to do your solve and share, all the angles just don't have to be in this position. So once again, we have our what? Our perpendicular lines for review. Okay, now, so let's look at this right angle. So there's a right angle there. But look across. What's that again? Right. That's the line of symmetry, and line of symmetry, very good. And that's also a right angle. Line symmetric, top and bottom, the line of symmetry. That too is a right angle. And finally, top and bottom, line symmetric from last week's lesson. The line here is your line of symmetry. And so we have a right angle up top, and if they both are line symmetric, then we have our fourth right angle. So just keep that in mind when we get to your solve and share, okay? So that's the right angle. And then we also discussed what is, excuse me, an acute angle. So we'll put, just as a quick sample, we'll put our benchmark angle again out, which is your right angle. And how many degrees did we say that a right angle is altogether? Right. It goes from, a right angle is 90 degrees, okay? Not 89, not 87, not 94, exactly 90 degrees. So how did we determine an acute angle? So an acute angle was any angle starting from 1 degree all the way up to 89 degrees. So that's an acute angle. Okay. That's an acute angle because it's still not 90. And of course, that's an acute angle. We could go all the way up here. Because none of those angles touch that 90-degree line there. So all of these angles, by definition, excuse me, would be an acute angle. Okay? So I'm going to move forward, but you all can always pause to review right angle and acute angle. Okay? And then finally, we have a right angle, we have an acute angle for review, and then we had what's called an obtuse angle. So we put our benchmark angle back up again. So what would constitute an obtuse angle? An obtuse angle, boys and girls, is an angle that is greater than 9 degrees. And remember, if you didn't remember what this sign meant again, remember in class, the Pac-Man or Pac-Woman always eats the larger number. So anything greater than 90, okay. This angle is past 90. Starting from 0. This angle we know that is greater than 90. And I'll just do one more for argument's sake here. I'm going to do one way down here. So this angle definitely is larger than 90 degrees. But, so an obtuse angle is greater than 90 degrees. That means 91, 92, 100, 103, 104, 100, 150. But remember in your song there, boys and girls, when we was dealing with angles, what did your exercise tell you here with this straight line? Absolutely right. This straight line is called the straight angle. And from review, we know that a straight angle, we learned it is line symmetric from side to side of the right angles. So that means they are what? Both the same? So a right angle, if one side is 9 degrees, and the other side is 9 degrees, then to get a straight angle, it is 180 degrees, right? So, an obtuse angle, yes, it's larger than 90, but it is less than 180 degrees. So we put the Pac-Man or Pac-Woman here also, because the Pac-Man or Pac-Woman eats the larger number. So an obtuse angle, it will start from 91 degrees and it will go all the way to 179 degrees. That's what an obtuse angle is all about. Okay? Now, so having said that, now this is a time, boys and girls, where we would pause again, because we would come back to our solve and share. Explain how you sorted these 7 triangles. And what I want you to do in your distance learning environment, of course, you will put your answers in your private messaging for me to look at in your Google Classroom. So, yes, we paused and we've talked about this solve and share. Now it's time to figure out, how did you sort it, or how did you put these triangles into different categories? Okay, you said sides, sizes, and angles. Okay, let's talk about it. Okay. Now, what did you all do here with this? Okay, I heard somebody say that they put them in the category of some of the triangles were in the category of two equal sides. So what do you mean? Okay. So triangle A has two equal sides, 6 inches and 6 inches. Triangle C has two sides the same, 6 inches and 6 inches. Triangle D has two sides that are the same, 5 inches and 5 inches. And triangle F has two triangles that have two equal sides, 6 inches and 6 inches. Okay, so if that was the case, you would put triangle A, C, D, G, okay, F, right? Okay, that could be an example. What other way can you categorize it? Okay, someone says that we can put them in a category where with triangles with 3 equal sides. How many categories did you have with 3 equal sides? B. Very good. How else could you categorize? I'm sorry. Then we could, right, very good. Then we could put them in the category with 0 equal sides. And what triangle has no equal sides here? Well, look at triangle E. One side is 2 inches, one side is 4 inches, one side is 3 inches. So that's a triangle that has none of the sides equal. So we're going to put this triangle right there. Okay. Now, we see, okay, what other ways could you categorize them now that we've had our review on angles? Okay. I'm going to erase this and you can go back and look at this at your leisure. Let's categorize some of these triangles here with acute, right angles, and obtuse angles. Could anyone tell us an angle that you see up here that has an obtuse angle? Okay, that means more than 9 degrees. That should have been angle F here. So we're just going to do an example or two of each. Any right angles? Okay, someone said E. What's that? Oh, someone said, Mr. Stuckey, automatically C because we already see the right angles symbol. So we'll just put one there. We're not going to do all of them. And then what about an acute angle triangle that has less than 90 degrees? Very good. So if someone said G. So we did not do all 7, but that's just an example, dear boys and girls, of how you could categorize these triangles here. You can either categorize them by lines. They all have 3 lines that's exact. Only have 2 lines that's the same, or have 3 lines the same. And we can also categorize triangles with different angles, acute angles, obtuse angles, and right triangles. And so finally, boys and girls, in step C, we're going to look at two students' work, and we're going to see how did these students categorize their triangles, why they put them in a place like they did.